So good morning, everyone, and welcome to this CIB webinar on smart cities. So we have now the topic of this webinar is the roadmap on smart cities, which is now open for the comments, and we are giving you the presentation of the roadmap. So my name is Miimo Airaksinen, and I'm a professor in VTT, which is the Technical Research Center of Finland, and I have been coordinating this task group on smart cities. And our program today is that we are firstly shortly giving you the introduction of the roadmap, and then we have the pleasure to hear three perspectives from smart cities, namely one from Europe, one from Northern America, and one from Asia. And after each of the presentations, you have the possibility to ask questions or have the comments, and of course in the end of the session as well you have the questions and answers. And kindly use the chat option for the questions, and please address them to me, so to Miimo, that I can then share them for the different speakers. Right. So then we can start with the overall picture of our roadmap, which is the smart cities. So our aim was to complete the CIB's community's vision and perspective for the future cities. And as we all know that the smart cities is really a big, kind of like really big and complex issue. So we wanted to focus on CIB's perspectives and not really to start the whole smart cities, because that's of course a lot of social and other things as well. So what we have done then, so we started to address that what are the current challenges and in respect to political, social, and market and environmental technologies perspectives, and then we tried to based on that, so we defined the smart city context and the frame and the vision where we want to go, and then the steps and the roadmap for the vision. For the methodology, so as I said, so we had the frame and the state of the art, so where are we now, and then we defined the future scenarios and then how we go step by step for the future. And for the process, so we started in February 2014 when we identified the priorities. And we had also the roadmap framework, so the problems and needs. And then later on in September, we have other workshop where we define more detailed the vision and also the development strategy and kind of like the steps for the roadmap. And now we are in the phase that we have defined and developed the initial roadmap, and it's now open for all of your comments and improvement, and then we can finalize it. As a backbone for our work, so we all agreed that smart city should be based on the sustainable city, that we have the balance on society, economic and environmental perspective, and we all see that technologies, not only ICT but other technologies as well, so they are kind of like enabling for us and for the cities to make the system work more efficiently, more environmental friendly, more economical beneficial. So that was kind of like the background idea there, that technologies are needed to make cities to work more efficient. In the workshop, so we identified different priorities, namely energy, of course, because low carbon energy is seen everywhere, and renewables. Then the buildings, new solutions, not only for the new buildings but also for the existing stock. Land use is of course, and other infrastructures in the city, not only the buildings, and the asset management. Those are the important ones. Then transport, of course, when we are speaking about the cities, and then communities and users and there we saw that people participation and on-demand services and trust and security and well-being issues are the important things in smart cities. In the workshop, so all those priority areas, so we identified the problem and need based on the kind of like policies and markets and products and services and technologies. And then we identified the reasons for those problems and possible solutions and kind of like visions where we wanted to go. So this we had already done in the previous WebEx, so I'm not going really in detail, but you can read this on the report then. Here you can see the other priority areas as well. Then in addition to the regions and where we want to go, so we were also going through the barriers. So what are the barriers for these specific topics, administrative and legal barriers, technical and infrastructure barriers, economical and market, and then social acceptance and possible political barriers. And in addition to these priority areas, so we also identified that we have cross-cutting issues like interoperability and ICT and resource management and environment, which we could see in all of those. So we were addressing the barriers on those topics as well. Then we created this thematic vision for all the different areas. And when we were analyzing these thematic visions, so we could see that actually it was really common themes there, kind of like low emission, zero carbon solutions, sustainability, integration of different systems, that we have many stakeholders, flexibility and resiliency of the systems. We need real-time information, how to use that real-time information in the best possible way. We need also like user-centric systems and well-being must be encouraged. And more importantly, that we need personalized services and of course, in order to make all those systems to live and fly, so we need the economic viability. So those were kind of like common themes in each of the priority areas. And kind of like based on that, so we created a CIB vision of the smart cities, which you can read here. So this is kind of like based on our ideas, but of course, once again, if you see even better ideas to create the vision, so we're happy to improve this vision. Then we make the roadmap for the main categories, so really the steps, how we go further, and I'm now giving you really the short introduction to those. So for the energy management, so we created them kind of like current situation, then short-term, medium-term, and long-term visions for the standard and policies perspective, operation and management perspective, technologies, and then planning and design perspectives. And once again, you can see that the data, interoperability, optimization are the core things there, and of course renewables and low carbon energies, but also the co-creative design and different and many stakeholders are highlighted here. And when you see then the district energy and issues, so once again you can see that actually even though the perspective is a bit different, so it's still the data, sensors, co-creation and stakeholders are once again user-centric issues are repeated. And when we go further to buildings, so we can here also see the communications and interoperability and data, but also security issues, cybersecurity issues, personalized services, data issues, cost efficiency, and integration. Same applies to infrastructures, so highlighting again services, monitoring and personalized services, embodied networks in the infrastructures and full integration of different infras and optimization of those. For the land use and urban planning, so multidisciplinary and integrated design and operation was highlighted. Also, like interoperability of different city models and harmonized data and efficient data use for performance analysis and planners and synergies. And low carbon, of course, low carbon solutions are highlighted here. For the mobility, again, of course, low carbon energy sources, but also the on-demand services, mobility as a services, and of course automation in the transport systems and mobilities. For the community and citizens, so again, the services, on-demand, timely services were highlighted, and also kind of like the user awareness and positive feedback and encouragement for the good and sustainable solutions. So as a conclusion, so we saw really clearly that digitalization is the enabler for new services and innovation in the smart cities and for the more efficient city systems. We saw that integrated planning and management is one of the core and key issues, and kind of like integrating all of the many stakeholders which are in the city systems. And we saw that value chains are changing, and we have new ecosystems coming in the smart cities. Low carbon energy and new type of energy management systems are coming, and also the new services and kind of like mobility as a service and building as a service, good air quality as a service type of businesses are coming. Also, the resiliency, flexibility, safety, and security issues were seen extremely important in the roadmap, and then the upgrading of existing stock, and that was also highlighted, including the new models of ownership and kind of like return of investment models who is really making business of those upgrading and low carbon solutions. So those were the main conclusions, and as said, so we are sending all of you this roadmap for feedback and improvement and comments that we can finalize it. Now we are going for the part of the WebEx where we have the three perspectives on smart cities. Our first perspective is from Europe, and we have the pleasure to hear from Dr. Gillian Hobbs her perspective about the smart cities. Gillian has been working many years in the field of sustainable urban development, sustainable communities, and low carbon design, as well as building performance evaluation. So she has really strong and solid background on this field. So welcome, Gillian. The floor is yours.
My name is Gillian Hobbs. I'm Strategy Director at BRE in the UK, and I'm going to talk a bit about future cities and the work that BRE have been undertaking in the last few years, and some of the perspectives that we've come up with since. So for those of you that don't know about BRE, we stand for a building research establishment. We've been working in the field of the environment since the 1920s, and our mission is to build a better world together. And we do that through a variety of research. We develop products, standards, we carry out training, and BRE is actually owned by a charity called the BRE Trust. So the profits from BRE are gifted to the Trust, and then that is used to carry out research, to support educational programs, and to also produce various publications, typically linked to the built environment. So from 2012 to 2015, we had a thematic program that was looking at future cities research. So we had a large number of collaborations, so over 70 partners. BRE Trust put in over £5 million of funding, and we, because we were partnered with various other people, collectively the project value was in excess of 30 million. So we looked at a whole range of issues connected to how do you make cities work better? You know, what are the core bits of information and research that need to be undertaken? mainly linked to the built environment, but not exclusively so, but can help us get from where we are now to the objective of having better cities into the future. And so, for example, some of the areas we looked at, we did a lot of work on sensors and monitoring, so you have the data available in the form that you need it in order to make the right decisions. We had a big part of the program was looking at indoor air quality and also outdoor air quality. We just had some news today that basically shows that about 40,000 excess deaths are caused each year in the UK due to air pollution, both indoor and outdoor. So there's obviously a lot of work that needs to be done there. Energy optimization, we're doing work on district heating, but also having systems whereby, for example, the input of renewable energy can be used most effectively with other energy sources. Resource efficiency, I'm going to talk a bit more about the resource efficiency and also the healthy cities work that was done. So what this is showing here is really the fact that we've done a lot of work on sensors and monitoring. So this is real-time sensor and monitoring. And a lot of this is focused on existing buildings, understanding the performance of existing buildings, either to make sure that they're operating the way that they're meant to be within the existing building management energy systems, for example, but then also it can be used for other reasons. So, for example, if you're planning to do refurbishment, you can get a much better understanding in terms of how that building should be refurbished in order to optimise performance in the future. And we're looking at a whole range of issues, so the temperature, the humidity, occupancy, all kinds of, CO2, and all of this information can be used for a variety of reasons so that we have a really much better understanding of how existing buildings are performing, and crucially, how the occupants of those buildings are affected by that building's performance. So you can see the picture in the corner is of moisture leading to mould being created, and obviously those spores are then bad for health. So those sorts of issues are really critical, and you can't, if you're focusing on energy, there's other issues that need to be looked at as well to make sure that the building is performing in the best way it can for the occupants of those buildings. Another project was looking at resource productivity, so looking at the use of resources, so the creation of resources, for example, wasted materials, and then the optimal use of those resources within a city environment or within a local environment. And what we wanted to do was to have a comparison of scenarios, so looking at the existing scenario, but then also looking at alternative scenarios and understanding what would be the benefits or the impact and the benefits, and we looked at that from economic, social and environmental perspective. So the first one I'm showing here is really looking at an evaluation of municipal waste, so domestic waste, but we built up information across multiple waste streams, so municipal, construction, demolition, commercial, industrial, agricultural. So by having that overview, you can get a much better idea in terms of where are you now, and then what would be the benefits of perhaps moving to a system whereby you had greater energy recovery, or you invested in more recycling or more anaerobic digestion facilities, for example. And so this shows you here, we've got the chart in pink is the current situation, the chart in green is the typical regional information you would get for that sort of urban environment. And then the alternative scenario is where we basically said, right, okay, what if you, for example, increased recycling to 75%? What would be the impact of that? And you can see that this is a cost revenue chart. So below the line means that you're making money from the resources available within the city. So you can see that in this particular example, the existing scenario, no, you're losing money, sorry, below the line you're losing money. So in this existing scenario, actually the least cost option is going to move to a situation where you're optimizing the recycling of those resources because you're gaining revenue to offset the cost of managing those materials. Then we looking at the carbon impact of the same scenarios. You can see once again, you're getting significant benefits in terms of avoided carbon impact by moving to a situation where the amount of recycling is increased significantly. And then looking finally at the job creation, once again you can see that the alternative scenario has benefits in terms of job creation. The idea of producing this tool was to have a sort of quite a high-level evaluation so that policymakers, for example, could quickly see that actually by investing in a certain way to operate that city or that urban environment, they could get significant benefits that they're currently lost opportunities. Another example of some work that's been undertaken is to map on a much greater scale, looking at the impact of excess cold and low income. So if you map the data layers of excess cold within the area, but then also where the pockets of low income are, then you can automatically see where you need to be targeting your effort in terms of supporting those vulnerable households. And this is work that's being undertaken now, so this information is being used at the moment to make sure that those people that could potentially have significant health impacts because they're suffering from excess cold, because they can't afford to heat their homes, for example, then the community and also the municipality can target their resources to help those particular households and make sure that they don't suffer unduly. And then what we've tried to do through this project is to have more of a holistic, balanced scorecard approach to cities and understanding the healthiness of cities. And in developing this work program, we tried to create scenarios whereby we could actually have indicators that could measure the healthiness of cities, predominantly linked to the built environment, but not exclusively. And you can see that there's a range of issues there, and there's obviously quite a lot of commonality with these issues and the roadmap that was outlined by Mimi earlier, because these are the areas that affect the resilience and the healthiness of cities. And the idea of this index is that you can get a quick snapshot of an understanding of where a city is performing and where it's underperforming, and then you can have more targeted programs of work to raise the performance of those areas. Another aspect, because of the current thematic work that's going on, is about resilience. So from 2015, for the next 2 years, we'll be looking at resilience, but there was a crossover in terms of looking at the resilience of cities. And this is really looking at a resilience rating. So the report has just been published. You can see the title there. So you'll be able to download it free of charge from BRE Centre for Resilience website. And this is really looking at what's the capacity of a city to respond to events, and then also what's the demand in terms of being able to respond to those events. And ideally you want them to be equal, but inevitably there's going to be a gap across a whole range of issues. So really the resilience rating is trying to understand where the gap is and then put in place measures to reduce that as far as possible. And obviously this will be highly variable and depending on the local context and the drivers and the impacts of those cities. So the 12 city assessment shows the sort of variety of concerns and issues that are affecting a city's ability to have this high resilience rating across the world. And again, it's just a really a high level way of identifying where the priority areas are. And I mean, with this, I basically, we're talking about smart cities, but actually, we want better cities, and I think there's various strands of work that are going on about creating better cities. And although they're shown here as sort of separate, distinct activities, actually there's a lot of overlap between them. And So we have the smart cities where you've got greater integration of the physical, digital, human systems to have effectiveness and efficiency of the services. You've got livable cities, so places where people actually want to live because there's a vibrancy about it, there's a high quality of life, people feel safe, they've got good access, good provision of housing, transport, employment, all the things that people need in order to thrive in a city. And we have the healthy cities that we've been through. You want people to be healthy within the cities, and there's various constraints that make that quite difficult. Traffic being a key one that creates air pollution. And then we have the resilient cities, because the idea of resilience is you don't just have the ability to cope with when things go wrong, so flooding, for example, or a drought situation, or there's an incident, a terrorist incident. It's not just about being able to cope with that, it's also being able to come back stronger and better from when those sorts of things happen. And it's the sort of thing that has to be built in over a long period of time and sustained over a long period of time. So just my final slide is really to make a plea, I suppose, to act smarter, because there's a lot of activity in the whole area of cities. And I actually think there is a shortage of information. There's a lot of information out there, but is it accessible, and is it available in a way that people can use it to make those sort of decisions and to understand how they need to prioritise actions and policies and infrastructure going forward? I think there's still a big knowledge gap, and ideally you want to be able to have this really robust understanding of baseline performance. And from that, you can then prioritise where are the areas that you're going to focus on to make your city a better city, or to put in place a framework to enable all the cities within a particular nation, for example, to be a better, smarter city. And I just thought the whole acronym of SMART was quite relevant here, because if you look at many of the programmes that are going on in terms of smarter, better cities, I think there is, real need to be more specific and more measurable in terms of what's actually going to be done. There does need to be a greater consensus, so that, the people that live in that city, people that work in that city, I think they need to be brought into this whole programme of improvement in a better way, in a more meaningful way. And obviously everything has to be realistic, achievable. There's no point suggesting that you're going to move to a highly integrated, efficient system when you've got a huge amount of existing infrastructure, and you have to make sure that it's possible to make sure that is part of the future progress of the city. Then also being able to do things, and the short, medium, long term, again, is an important aspect of smarter cities. And if you're going to set targets, make sure they can be trackable, make sure you know is progress being made. If not, have a rethink and carry on. So really just leaving with a briefing paper that was produced, which was Citizens Systems, which sort of talks through some of the things that I've been mentioning today. But it's really about the fact that everything ultimately is integrated, and you need to do things on micro, macro and in-between levels in order to make these things work effectively. So thank you.
Thank you. Thank you, Gillian. Thank you. That was really interesting presentation. We have a few questions for you, Gillian. I mean, there's one question about that. Do you see there is a difference between smart, healthy, resilient, and a sustainable city, or should there be a difference, or do you see that is actually it's the same thing, or how would you define it?
Well, I think so the program that I went through, or some of the elements of the program, was called Future Cities, and actually, so I don't necessarily think we should be just aspiring to make things better in the future. We should be working in the here and now, and I actually think it's a combination of all those. So maybe we just need to be thinking about better cities. and there are elements of creating better cities. There's a smart element, there's a resilient element, there's a healthy element, and there's a livability element. And actually there is sort of overlap between some of those elements. So I think it's, you know, maybe we need to be thinking about specific thematic areas that need to be improved. And I think the roadmap that you went through earlier, it shows that there's, you know, that there's some sort of, there is a consensus, I think, in terms of some of the key areas that make a better city or a worse city, depending on how the performance is. And maybe if we can agree, you know, these are the things that make things better and these are the things that tend to make things worse, then we can start to focus on quite practical ways to make things better. And there are still knowledge gaps, and I think the roadmap will obviously highlight where the knowledge gaps are. And then in the meantime, we need to be working to plug those knowledge gaps.
Right. Okay. Thank you. Thank you. Then there is also other question about related to this issue. So it's about that how we should then measure, or should we measure, or should we kind of like set some values? What is then good rating for sustainability or energy or what people engagement? Should we have kind of like rating systems there, or should we have more kind of like that we have direction that if you do these and these things, so that is enabling things, or shall we have like exact numbers, or what is your opinion on this?
Well, I mean, I've always found that knowledge is power, so having good data and an understanding of performance is always a very good way to then set targets and measure whether or not you're reaching those targets. But obviously, setting a target and having the baseline information in itself won't necessarily improve things, so it has to be accompanied by actual activities and actions and to address particularly areas of weakness. And I think the excess cold example was quite a good example of showing how we have a lot of the data and you can overlap it and you can understand what is, where you like to get pockets of excess cold, and that's actual quantifiable data that you can use to see, right, okay, we know that those people in that area, because we also know that their income is low in comparison to the rest of the population. Again, it's a data issue. We know that they're going to be suffering from excess cold and they'll have all the health impacts associated with it. But if nothing then happened, then what would be the point of collecting that information if it wasn't then linked to a program whereby, for example, they got offered free installation, or they received a grant towards paying their energy bills? There has to be a correlation between the fact that you've identified that there's an area that needs to be prioritised and an action that then happens, because otherwise collecting data, the sake of collecting data, is a bit meaningless.
Yeah. Yes. Thank you. Thank you. That was really, really good point. We still have like one question, and it was related actually to the data and the sensors. You were mentioning in the beginning of the presentation the sensors. So how do you see the reliability of the data and also the level of detail of the data? So how you address that? Because we went for the highest. Yeah. So the work that we were doing was actually. Yeah. So the work that we were doing was very detailed analysis and sensor information, and we did have problems with the sensor equipment because, to a certain extent, it was actually research to look at different ways and different sensors, the hardware as well as the software, to take the data and turn that into meaningful analysis of what was happening within the various buildings where the monitoring equipment was. So I certainly think there's a lot of progress that needs to be made in terms of not only
reliability of it's not so much the sensors are quite reliable, it's the hub, like the smart hub that pulls the information together and then transfers that to a software or a web portal that can then analyze that data. I think that's the bit that seems to be quite weak, because we're relying on broadband or we're relying on sort of mobile data, and whenever you're doing that, then there's always a cost implication. But also, if people don't switch the broadband, just really simple things. So if people switch the broadband off because they think it's costing them money, or they go away and they switch all the electricity off, then you're automatically then not getting that data, because the technology that you're relying on to transfer that data to the web portal where it's all being collated, you've lost that link. So I think there's definitely, I don't know what to call it really, an interface transfer of data issue that needs to be resolved, because the sensors are very reliable, but the bit in between the sensors and the web portal collating the data is quite variable in terms of reliability.
Okay, thank you. Thank you. That was really, really interesting and good. We still have a few questions for you, but I mean, we are postponing them to the final remarks, that we can go further now with the second perspective of smart cities, which is given us for the Dr. David Wollman, and he's working for the NIST, National Institute of Standards and Technology in States, and he has been working really extensively for the smart cities, and especially on the smart grid interoperability standards and cyber physical systems, and also like urban campaigns. So and NIST is also leading in the smart city initiatives in the state. So that is also what they are doing. So welcome, David, to give your perspectives on the smart cities. So the floor is yours.
Thank you so much for the invitation to talk and follow the rollout of the CIB roadmap. I'm happy to discuss the perspective in the United States and North America. As Mimu mentioned, I work for the National Institute of Standards and Technology. We're part of the United States Department of Commerce in the U.S. federal government. I'll cover a couple areas this morning that I think are relevant to the CIB roadmap. Mimu already has mentioned cyber physical systems, which includes the concepts of the Internet of Things. We've had a public working group looking at that area, and it's developed a draft framework, and there's some parallels with the CIB roadmap that I'd like to mention. Then I'd also like to cover the growing interest and support for smart cities, both in North America as well as the rest of the world. We have our President of the White House interested in smart cities. There's a White House Smart Cities Initiative, of which our own activities, the Global Cities Teams Challenge, is part of. And then we have a new effort that is starting, a new international working group looking at Internet of Things enabled smart cities and developing a framework for that, which I think will be of interest to the audience. Let me start with cyber physical systems, also including Internet of Things. We've had a public working group composed of experts from industry, academia, and government working together to develop the foundation for cyber physical systems. This effort, there's a website that's listed here where you can find all of the material. This effort has produced a framework, a draft framework, a technical foundation of concepts for cyber physical systems, which underlies smart cities. And we're currently revising the framework based on public review comments. In the upper right, you'll see that cyber physical systems combine the cyber and physical components in an information, decision, action, and physical state loop that can be both at the system level, you can dive into components at the device level, or you could be broader with the systems of systems concepts, and that these interactions that form these cyber-physical systems also, very importantly, include human interactions. Overall, this process has revealed a way to understand the system engineering process. If you think in terms of facets, it's a word that we've devised to span that cyber-physical system development process. And there's three key facets. There's the conceptualization facet, where you are understanding the requirements of what you're trying to design. You're producing a model for how the cyber-physical system will work. In the realization facet, that's where you're making the trade-offs, the design trade-offs, and producing the actual cyber-physical system and doing testing and making sure that it will operate correctly. And then also there's an assurance facet, which is sometimes overlooked but is also very important. You, in many cases, will need to assure the public or the folks purchasing your cyber-physical systems that you have realized the actual working system and its properties map onto what you had conceptualized them to be. So it's kind of like the proof that you've done the work that you have claimed to do. This facets is a collection of activities and the results of those activities. So that's why I mean it spans the system engineering process. But at the same time, you're going to have many different stakeholders and domains. Those domains and stakeholders will have concerns. Those concerns are going to need to be addressed throughout the system engineering process. That's where we have the concept of aspects. So these are collections of concerns in the areas listed here: functional, business, human, trustworthiness, timing, data, boundaries, composition, and life cycle. These collections of concerns need to be addressed at all parts of the system engineering process. So in each of the facets, conceptualization, realization, and assurance, you're going to have those concerns identified and addressed. Their properties either then will be made provable through the assurance activities. One particular aspect or cluster of concerns I want to point out is trustworthiness. We had a subgroup that was composed of cybersecurity and privacy experts, and they identified an even broader concept of trustworthiness, where you want cyber-physical systems that you can rely on. And these are going to need to have security, privacy, safety, resiliency, and reliability all together to make something that you can rely on. One of the interesting things is that each of these areas has a risk management strategy and approach, and it's this combined risk management approach that's going to be necessary to produce systems that are trustworthy. So let me very quickly look at the alignment of concepts. Mimu did an excellent job of describing some of the key components of the CIB roadmap and some of the concepts, the cross-cutting concepts. And I want to show you here that there's a lot of similarity and overlap with this work. So this is very good. This is showing that we're having thinking that is aligned between our different activities. The CIB roadmap revealed the importance of digitalization. In the CPS framework, we talk about information technology coming together with operational technology, but both of these are enabling new services and innovation. In the CIB roadmap, there's integrated planning and management. This is very important, and one of the goals of our cyber-physical system framework is to enable integration at multiple scales. I mentioned devices to system of systems, and the planning portion of it, there's a lot of interest in co-design, being able to engineer these systems. A lot of that is found in the conceptualization facet, where you have a model of the cyber-physical system. Again, we both have stakeholders, and we have domains and concerns that are organized into aspects. For energy management, we've identified energy management as one key use case. Mimu mentioned the work that we've done with Smart Grid, and so that makes it very easy to look at those interconnections with the infrastructures of cities. New services are very important. I've already mentioned trustworthiness, and there's a lot of good parallels with the resiliency, safety, and security issues identified in the roadmap for CIB. When it comes to buildings, models, etc., we are very neutral on the business models, but we have a collection of concerns around business to help identify and treat those concerns. So let me now start getting into the broader perspective on smart cities in North America and the U.S. There are growing interests in this area. One way you'll notice that is through many different parts of the United States federal government have come together and are working together. I mentioned the White House Smart Cities Initiative. This is an activity that is supported by over $160 million of federal research, and it involves activities of different agencies, and even President Obama has pointed to the needs of communities. Within our own activities, I'll mention the Global Cities Teams Challenge next. We also have our National Science Foundation, which has done a lot of research funding, but to give you an example of one that is currently of great interest to the cities, we've had many of our cities apply for the United States Department of Transportation Smart Cities Challenge. So this was putting up a significant amount of funding, up to $50 million, to fund one medium-sized city that is making a smart city through transportation, making transportation safer, easier, and more reliable. And they've had 78 cities apply for this particular funding. It will be announced in the upcoming months once they review it. Now I want to talk in detail about the Global Cities Teams Challenge, since I think it's very relevant to our conversation today. One of the things that we've tried to do is to spark some collaborative effort and innovation with cities working together with technology innovators and other partners. Our idea is that if we can get groups of cities interested in particular issues and problems and have them talk with each other, they can benefit from interactions with technology innovators. But most importantly, this will allow for multiple cities to benefit, and the resulting solutions will be more likely to be broadly applicable, to be replicable in many cities, to be scalable to different sizes, and sustainable. Since we are the National Institute of Standards and Technology, we also have a very strong focus on measuring things, and so we want to see that these demonstrated models have measurable benefits in smart communities and cities, and that's an important component of our most recent Global Cities Teams Challenge. We had started with a version of Global Cities Teams Challenge in 2015, and we're currently in the 2016 component. This gives you a visual representation of the international interest in this. We've tried to make this international. We have many partners within the United States government, and there's an upcoming meeting March 22nd and 23rd here at NIST in Gaithersburg, Maryland, in which the current 2016 participants will present the current state of their project and continue to recruit partners. Now I want to move on to our work to establish a new international working group. We've realized that with the Global Cities Teams Challenge, we've had some insight into how different cities have tackled some specific issues, such as communications and kiosks in New York City, to doing sensor networks to help the elderly in our own local Montgomery County and in cities around the world. This information and understanding of the architectures behind the Internet of Things enabled solutions is going to be very important to help cities understand how to put technologies together. You may purchase items from different suppliers, and you want an overall architectural concept that is able to combine many of the advances. Since smart cities technologies are being developed rapidly, and we want to take custom solutions and turn them into more generally applicable solutions, there's a wide variety of these architectural design efforts. What we've done with the partners listed below on the slide is convene an international public working group to look at the architectural features behind the smart cities with the goal of not reinventing anything, not a standards activity. This is more of a description activity to understand a reference framework for the development of architectures for composable smart cities. Our strategy here is to do some analysis of different architectural concepts. This includes things like spyware, IoTA, the Industrial Internet Consortia, and others, and look at how those approaches and architectures have commonality. If we can find some of those common features, it doesn't insist that everything be the same, but it gives an opportunity to identify common pivotal points of interoperability where with some additional work, you could have different architectural activities support each other, and we can use our framework, our cyber physical system framework, as a way to just map and keep track of some of these important concepts around the architectures. This slide gives some of our time frames. We're kicking off meetings both in the United States right after our Global Cities Tech Jam here in this Gaithersburg, and also our partners in Europe in April are going to have a kickoff for this activity in Rome. And then the process is described here with 3 working groups on applications, the pivotal points of interoperability on the design portion, and then a deployment. So with that, I'll conclude. Here are some contact information that is available. We have a team here that is quite interested in engaging with the broader international community. And so with that, I'll stop and turn things back to Mima.
Okay. Thank you, David. I mean, that was a really interesting presentation. We have already many questions to you. How do you see that, what is the role of building and construction sector in the smart cities, since we can see that there was a lot of data and ICT and Internet of Things. So how the construction sector is integrated and engaged in this development?
Thank you for that question. It's an excellent question. At NIST, we have a buildings groups and divisions. We've included the buildings component very actively in smart grid with the smart buildings connecting to the smart grid, and that has continued into smart cities where the role of buildings is well recognized as being essential to the urban environment and performance. Another key infrastructure is transportation. That's another one that many folks are interested in the smart cities context. So some of the activities that we've had with our Global Cities Teams Challenge have specifically looked at buildings. Sometimes it's their participation in energy markets through such concepts as transactive energy, flexibility in the European context. And there's also been significant interest in efficiency, virtual energy audits. So all of these different concepts, there is a strong building presence in the smart cities activities, and it's very good to be able to mention that. Thank you.
Okay, thank you. Thank you. Then there is also another question about, you showed these initiatives about the smart cities, and it was really also many partners in Europe, and there might be also some partners which are not yet engaged but would like to be. So is that still open for that you could engage your institute or city for that, and Are you searching more on the city partners or institutional partners for that program?
We're definitely interested in more engagement and partners. The last slide that I had the lead for it, Marty Burns, martin.burns@nist.gov, and so he would be the contact person for this. And on the slides there was also a website that described all of the activities in more detail. So we are we have a core group of institutions that are helping to launch this activity, but we definitely want more interactions with the broader set of folks, because we want to make sure that we're identifying all of the key architectural concepts, particularly if there's an architecture that an organization has that they would like to have be analyzed as part of this activity. That's where we're particularly interested in additional participation.
Okay, wonderful, wonderful, thank you. Then one last question for this. So you were mentioning also that you're actually using the same terminology as in European cities. So you are talking about lighthouse cities. And one question was specifically that, are you also focusing on the energy systems and mobility issues and integration of those? So is that one of the core themes also in your program as it is in the Europe?
Mobility has been identified as an important area, so I think that is a common point between the CIB roadmap and the Smart Cities activities that we have. We haven't yet identified it as a separate working group, because with the current set of working groups we've had, particularly on the cyber physical systems framework, it's been more cross-cutting in terms of all of the different concerns and the process by which you develop cyber physical systems, but it's very good input, the importance of mobility.
Okay, thank you. Thank you, David, once more about your really interesting presentation. We still have a few questions for you, but in the end of the session, since we need to keep the time. So thank you once more. And now we have the pleasure to have our third presentation about the perspective of the smart cities and from the Asian perspective. So we have Professor Jeffrey Chen from Hong Kong Polytechnic University, and he has been working with the smart technologies and value chain management and collaborate working in construction in many years. He is also heavily engaged in the Global Leadership Forum in construction engineering and management programs, and he has many years experience on the processes as well. So we wish you very welcome, Professor Jeffrey Chen.
Our time is in the afternoon, so good afternoon, everyone. My name is Jeffrey, as the convener has introduced. I also heard the questions raised to our previous presenters regarding how the building and construction community can contribute to smart cities. So my presentation today is more about how our building and construction community can contribute to smart cities. So I'm going to introduce a specific research project which looks into the use of 3D spatial analysis technology to investigate the possibility of minor relaxation of plot ratios and building height restrictions in a particular area in Hong Kong. But before that, I will also give you a bigger picture about how the government push the development of smart city in Hong Kong. So if I may, I can change to, how do I move to the next slide? Maybe just that? No. I'm trying to learn how do I move to the next slide. Okay, maybe this one. Okay, here we are. So you can still see the screen, right?
Yes, thank you. Yes.
Good. Now, this is a greeting from the Hong Kong Polytechnic University. This is my workplace. And in contrast to the previous two speakers, we are a university, and my specific department is building and real estate. In short, it's also BRE, interesting enough. Okay, now, before I go into the presentation, I would like to put things in perspective. I think there are many different definitions on smart cities, and there's no one universal definition for smart city, but there are some common features of smart city. Number one is a city that leverage on information and communication technologies and use innovative solutions to address issues in a city, including government, economy, mobility, environment, living, and people. And number two is to aim to improve the quality of life of the people living in the city and the sustainable growth and the competitiveness of the city through smart initiatives. So these are the two common features of smart cities, and you can see it's very broad. That's why we have people working in the information telecommunication industry. They are working in this area of smart city, but also building, construction, community planning, architecture, etc. So as I mentioned, my angle is primarily from the building and construction background. Okay, in Hong Kong, the chief executive has announced that this is recent in the 2015 policy address. The government would explore to develop Kowloon East, which is a part of the city, as a pilot area to explore the feasibility of developing a smart city. In fact, depending on how we define a smart city, Hong Kong has been regarded by some authority ranking, indexing agencies. It's already a smart city. But of course, we are a bit modest. We believe we are still having room to develop. So that's why we try to say we want to explore the possibility of developing in one possible pilot area. Okay, in this policy address, the government also mentioned that we want to examine the feasibility of using technology to enhance pedestrian and vehicular accessibility, managing district facilities and disseminating information to the public in digital format, etc., with a view to make the area a better place for work and play. So this is one of the initiatives introduced by the government recently. And when we talk about the smart city, we have these number of things in mind. Okay, apart from Hong Kong, you probably also know there are smart cities in other countries and cities in Asia, like South Korea. We have Seoul as a smart city, and Singapore as another smart city, and Tokyo in Japan. But I'm not going to touch the other smart cities, but to focus on Hong Kong in particular. So when we talk about smart city initiatives, we have the following items in mind: smart economy, mobility, environment, people, living, and government. So when we talk about smart economy, we have things like high-speed internet infrastructure and e-commerce, and we use widely this particular card called Octopus, which basically it's RFID card, which enable people to store value inside and use it in public transport, in canteens, in some supermarket, etc. So it's widely used. Octopus. So this is regarding e-commerce in our economy. In terms of mobility, we have a very good public transportation system, as you probably know. And we also have a very good freight logistics and traffic information system. But of course, there are still rooms for improvement. And environment, we have planning, land use, and smart buildings. This is particularly related to the building and construction community. Land use, smart buildings with zero carbon buildings, examples, renewable energies, etc. And smart people using mobile, broadband, etc., using ICT, and smart living, basically enhance quality of life through the means mentioned above. And e-government, there are a lot of electronic services provided by the current government. So this is the few things we have in mind when we talk about smart city development. Okay, then I move on to, this is another recent initiative called Smarter Hong Kong, Smarter Living. Within this, under this initiative, we have, for example, specific initiatives trying to develop Wi-Fi hotspots, trying to disseminate information through internet, try to digitize government operations, and Internet of Things, as David mentioned. This is something we have also a very good infrastructure and a lot of work into this area, sensors and big data, etc., and digital identity of citizens. So there's a number of initiatives under this Smart Hong Kong Smart Living program. And I mentioned Kowloon East as a pilot area. So basically the government wants to make this area a better place for work and play, and trying to incorporate technologies to enhance the pedestrian vehicular access, managing facilities, etc. And you make this place a workable place. So you don't need to rely on any means of transportation, but simply work from one place to another. And green community in terms of energy use, and also using smart technologies like Wi-Fi, wireless networks, etc. So this is the big picture. And look into the projects, and if you have the definitions I gave early on regarding smart cities, from the building construction community's perspective, this is one workshop we have organized quite a few years back in 2007 to look into collaborative human futures, how different professions can rely on technologies to support and collaborate. This is one of the end products called Collaborative Construction Information Management. This is a book edited by myself and other two colleagues, Peter and Andrew. Now, let me go back specifically to this research project. This is our team. As you can see, this is a very multidisciplinary team. We have people like Stanley Young, he's a town planner. We also have Abby Wong, and she is specializing in land use policies. We have Dr. Charles Wong. He specialized in heat island effect, air temperature, wind ventilations, etc. in the city. And Dr. Guo on data collection, spatial analysis, etc. So we have a few other colleagues as researchers involved in the project. Now, the background, so this is the few things I want to cover: the background of the project, research objectives, methodology, findings, and summary. A little bit background about the project. In fact, we look into the old CITES airport area. Some of you who were in Hong Kong before, you know we had, this is our old airport. And in 1998, we have moved the airport from this old location to the current location. So the old airports are now open for redevelopment. So what we are trying to do is to look into some of the land provision issues within this particular old airport area. As mentioned, we have a CITES development plan. As you can see, from 1998, after the airport has been moved to a new location, we have a number of initiatives by the government trying to redevelop this area. So I don't want to go into the details. For example, we have outline zoning plan for this particular area. Okay, now our focus. This is one site visit we have conducted. As you can see, there are a lot of construction work and land to be formulated for development. This is actually just a few months back when we paid a site visit to this area. Now, our focus is on these three particular areas. Altogether, 21 pieces of land. We look into the possibility of and the impact of minor relaxation of plot ratio and building height restrictions on a number of things, such as the skyline, the shadows, air temperature, wind ventilation, etc., to see what are the impacts. Of course, there are many other things we didn't touch. For example, excuse me, environmental impact analysis and transportation, for example. But our focus is to see how we can use 3D spatial technology to support our analysis in looking into possible relaxation of this 21 sites in this development area. Okay, now this is the three area as I've mentioned. This is actually the three, 1, 2, 3. Altogether, it consists of 21 pieces of land, and we want to look into how the relaxation may affect the lightings, the ridge lines, air and ventilations, etc., by using 3D spatial technology to support our analysis. So specific research objective is to investigate the viability of minor relaxation of this site in column 3 through 3D modeling and spatial analysis. So the two specific objective is to establish a 3D model and to conduct a spatial analysis of the different plot ratio, building height, etc., on this the impact, like shadow, solar exposure, skylines, etc. Okay, so I'm going to introduce those in detail later on. Okay. Now this is the research methodology. I think I already covered that we want to look into the skylines, the visual impact, the wind ventilations, shadows, and air temperature, to see if we relax the restriction, how this will affect all these different things in this particular development area. Okay, Now, this is the development of our 3D model. So we have bought some data from the government, which including buildings, infrastructure, and some terrains, to help us to estimate. This is the old airport, the runway, as you can see, and this is the area we try to develop our digital model. So it's not just the 21 sites we try to focus, but also the surroundings, because we will have some interrelations and interactions in terms of shadows, air, and the skylines, etc. So we have to buy to have the digital model for quite a large area of this part of the city. And we followed two things in particular during the scenario development. One is the outline zoning plan, the other one is the building regulations. So I don't want to go into the details. These are the, if you like, the constraints and the guiding principles we have to follow when we develop different scenarios. Okay, now vertically, this column represents one particular site. We didn't list all the 21 sites. This is just a few examples of the site. And what we have done, we have developed basically 4 scenarios, different scenarios. And scenario 1 is the current situation in terms of a plot ratio, in terms of building height, etc. And the scenario 2 is, as you can see from this particular illustration, scenario 2 is one already approved by the town planning board to increase the height restrictions and plot ratio roughly by 22%, already approved. But we want to explore, if we want to further relax, increase the height and relax the plot ratio, and so we create scenario 3 and scenario 4. Scenario 3 is half of this previous increment, and scenario 4 is the full amount of the previous increment. So altogether, you can see we have created 4 scenarios for all 21 sites and to look into the development. Okay, now you can see this is area 1, for example. We have actually somehow the animation doesn't work. We have animation to illustrate how the different scenarios change in terms of building height, etc. But anyway, you can have some ideas already. And this is the models we have developed for this new area, because this is still empty land. So we have used our imagination and use those constraints we have mentioned earlier, trying to develop a possible solution for this development. Okay, area 1, 2, 3. Okay, area 3 include commercial elements and also residential elements. Okay, so what we have done in terms of okay, now you can see the model. This is the area 3, area 1, area 2. So this are the models we have developed ourselves. This is a closer look of the area 3 and other 2 areas. Okay, now we come to the analysis we have done by using the 3D models. The first one we have done is the skyline. Now you can see this is one particular section. We have it's called Skyline 1, and this is another section called the Skyline 2. And if you go into the system, because of the 3D model, it can actually help us to generate this skyline fairly easily. We can compare scenario 1, 2, 3, 4, how the skyline change. Okay, because the height will be different, the plot ratio will be different, site coverage may also change, and to see how it affected the skyline. So this is one thing we have done, and this is the second line, a different cut. You can see the difference between the 4 different scenarios. And then we have done another analysis called visual impact on the ridge lines. For those who have been to Hong Kong, you probably know we have the Lion Rock Mountain, which is considered as an asset of the city. So all the development should observe the ridge line. This is of course not a compulsory, but it's a guideline. So we have done this, trying to look into how our development affect this ridge line. Okay, so if I show you this. Okay, now we have to use 3 particular points trying to look over to those ridge lines. So we have a point here, and point here. There are 3 different points, and trying to look over to this development area. So this is Victoria Harbour, if you are familiar with Hong Kong. And by looking into the mountains at the back to see whether the development we have here block our views of the mountains, the ridge line so-called. So this is the ridge line we have in mind, and what we have done, we have used the lines to go from these 3 particular locations and to see whether our views will be blocked by this new development. So as you can see, none of the views are blocked in all these different scenarios. So that's one result. We can say by having these 4 different scenarios, it does not affect the ridgeline at the back. Okay. So other analyses we have done include, for example, shadows and solar exposures, to see how these different scenarios affect the shadows and the solar exposure of this particular area and surroundings. Okay, we also have some animation. Again, it doesn't work. It actually shows 24 hours. How does it change? Okay, don't worry. So this is still solar exposure, and then we also did something like the shadows to see how it affects the lightings and those people who are living in this area. This is solar exposure. You can see the right are the area where you can receive the sunlight, and the blue are the shadows, and you can see the different area and the different scenarios. So by having this information, we can have it visually the information to facilitate the discussion. So this is spatial analysis. We have some data to show how the solar exposure may be affected by the relaxation. So without going to other 2 areas like wind ventilation and air temperature, because that will be too much. So just want to say, through this analysis, we have concluded that there are only minor effect on skyline, no visual impact on the ridgeline, slight change on solar exposure, slight change on wind and air temperature. So basically, the presentation I try to illustrate is how our building construction community can make good use of technology like what we are using 3D spatial analysis, GIS, CT engine, and to support the possible development scenarios. We don't have any specific views, but by having the data in front of people, it will facilitate the discussion. So that's all from me. Thank you very much.
Thank you, Jeffrey. That was really interesting and shows really the power of the visualization and modeling of the cities. We have one question about the cities, and you showed now the new cities how you are using. Do you have already experience on how do you develop the existing cities to smart cities?
Okay. As I mentioned, depending on how people regard what is the definition of a smart city. there are different ranking agencies already treated Hong Kong as a smart city. But the one we are currently developing is an existing area. And we try to say make this area more livable, more workable, and supported by ICT, for example. And this particular area is an old industrial area. I would say a mixture of industrial buildings and residential, commercial buildings. So the government already make some move to relocate some of the industrial buildings outside this area, and also trying to make this area more workable. So you don't need to rely on a lot of transport, either public or private transport. So you can go from, this is a relatively small area, so you can go from any point to any point by just using your 2 legs to get to that location. And also there are some initiatives trying to beautify this area, for example, by having some paintings, etc. But this is ongoing. As I mentioned early on, this is a so-called one pilot area trying to further develop a city, to redevelop a city into a smart city.
Wonderful, wonderful. Thank you. Thank you. Due to time constraints, so I'm actually asking the following question to all our presenters. So, what are the 3 key elements about in the smart city development, or can you mention 3 main key elements in the smart city development? Maybe you, Jeffrey, could start with the answer.
Sorry, say it again. Your question is?
The question from the audience was that what is the 3 key elements in the smart cities, or can you mention 3 key elements?
I would say buildings, environment, and the technology.
Wonderful, thank you. What about Gillian? Thank you. What about Gillian, your perspectives for that?
Well, I mean, I suppose I don't really have a clear definition of what a smart city is, but in terms of a better city, I think they should be inclusive. So I think everybody should feel part of the city and should thrive in the city. It shouldn't just be a few elements, you know, benefiting, and then you've got other elements that are really suffering. So I think inclusivity is key. And generally, it should result in cities being better places to live and work, and that's a key element of a smart city. And I think also on the whole competitiveness side, I think it should work for everybody. It should be good for business, and as well as good for the city economically and in terms of competitiveness.
Okay, thank you. And David, could you give your perspective?
Sure, I'll make a technical perspective. Architectural coherence, I think, is important. When I'm talking about architectures, it's technology architectures, not just building architectures. The Internet of Things, I think, will be diffused throughout a city and will be very important. And the third one is linked infrastructures. How our infrastructures combine, I think, will be very important.
Wonderful, thank you. Thank you. Due to time constraints, so unfortunately we cannot take all the questions. I mean, thank you for the audience. You have been really active and sending us the questions, but unfortunately the time is running out. I would like to thank you once more, our presenters, about the really interesting perspectives from different locations in the globe, and it was really interesting to hear your current knowledge and projects. Then a few practical questions about the roadmap and the comments. So the roadmap is now open for the comments, and we are sending it to you, and we are wishing many improvements and comments. The comments are, the roadmap is open for the comments for the mid-April, and after that we are arranging one more kind of like workshop webinar where we are implementing the comments and kind of like to once more seek the common understanding of the improvements. And then our plan is then to publish the roadmap in the CIB World Congress in next summer, so that is then the publication of the roadmap. Okay, so thank you once more for the audience for the active participation, and thank you for all the presenters for the excellent insights. And once more, we wish really active contribution for the commenting of the roadmap, that we can really give a holistic picture about our view of the smart cities. So thank you and have a nice day.